So let's look at our revenue function. Our revenue function is going to be R, and R is the total revenue collected after Q quantities are sold. So revenue is the money that a company brings in. And if you are looking at selling an item, then the revenue is the sales that you bring in. So the revenue is the total collected after Q units are sold. And the marginal revenue is the derivative. So the derivative is the rate of change. So the marginal revenue is the rate of change of the revenue. And the profit function looks like P of Q. And the profit is however much money you bring in. So the revenue you make minus the cost that you spent to produce the function or to produce the items. So we need to be careful. Remember back from the beginning when we talked about our cost function was our capital C. Our average cost was our lowercase c. So make sure that you're being clear right here when you're talking about your cost function. Don't let your notation throw you off. So our cost function is our capital C. I'll exaggerate it a little bit. There we go. So our profit is our revenue minus our cost. And then our marginal profit is our derivative of our profit. So our marginal profit is the derivative of the profit, so P prime of Q, and that's the derivative of the revenue minus the derivative of the cost. And our profit is maximized when R prime of Q is equal to C prime of Q, and our second derivative, our double prime of Q, is less than C prime of Q. So let's look at this. Let's see if we can figure out what this means. If a company's cost function for producing a product is this, and the revenue function is this, find the production level that maximizes profit. Okay, so we have a lot of information here. We're trying to figure out profit. So if we're trying to figure out profit, the first thing that we need is our profit function. So our profit is P of Q equals our revenue minus our cost. And so that would look like our revenue. So revenue is this one, 12.2 Q minus 0.002 Q squared minus our cost. Be careful. I would recommend putting your cost function in parentheses so that you don't forget to distribute your negative as you work everything through and try to simplify. So if we distribute this negative right here, there we go, and simplify this down, we'll have negative 0.006 Q squared plus 8.7 Q minus 2,250. I put the squared first because that's how we usually see it. So I just rearranged it as I was simplifying it. Now it's asking us to find the production level that maximizes profit. So whenever we need a max or a min, we take the derivative. So we have our equation for our profit function, so we need the derivative. So our derivative will look like 0.012 Q plus 8.7, and then the derivative of 2,250 goes to 0. So take your derivative, set it equal to 0. Let's move our negative 0.012 Q over. And then we can divide both sides by the 0.012. And if we divide both sides by 0.012, we get 725. So this is our only critical number. So let's put it back in. So C prime of Q equals, well, we didn't figure that part out yet. Here's our C of Q. So C prime of Q looks like it's going to be 3 0.5 plus 0.008 Q, and our R prime of Q looks like we will have 12.2 minus 0.004 Q. So let's check this. Remember, profit is maximized, and we're trying to maximize profit. Profit is maximized when R prime of Q is equal to C prime of Q. So we need to set these equal to each other. 12.2 minus 0.004 Q equals 3.5 plus 0.008 Q. So now we need to solve this down. If we combine our like terms, I'll move the 3.5 over, and that gives us 8.7. And then I'll add the 0.004 to both sides, and that gives us 0.012 Q. And then divide both sides by our 0.012, and it looks like we get 725 units. Look. We can solve this one down either way. So we were trying to find the maximum profit, the production level that gives us the maximum profit. So we started with our profit function and we worked it down. We also tried with our R prime of Q equals C prime of Q and worked it down. And in both cases, we got 725 units.